Hello, ladies and gentlemen. It is quiz review time. So we're going to start off with some radicals, some rational exponents, and then some factoring. First question here, we've got some exponent rules. When you notice that you have a quantity squared, you need to make sure that you actually square that quantity first, order of operations, as you get to do exponents before we can worry about this stuff, multiplication. So if you take x to the 1/2 to the second power, you're going to multiply. 1/2 times 2 is 1, so that's x to the first. Y squared squared is y to the 4th. Z to the 5th squared is z to the 10th. And then I'll just write x to the 3/2, y to the 1/2. So I won't do anything with those yet. Now what I can do is I can look and say, okay, you got x and x. When you multiply, you're going to add their exponents. So this is 3/2 and this is 1 whole, which I could write as 2/2. 2/2 plus 3/2 is going to give you a total of x to the 5/2. 4 plus 1/2, 4.5, you could think of this as 4 is 8/2. So 8/2 plus 1/2 make y to the 9/2, 4.5. And then z is just z to the 10th, so z is z to the 10th. Great. Do the same kind of thing here. 3/2 times 2 would be 6/2. That's 3. Y to the 4th, x to the 1/2, y. Now we're going to add. 3 whole is 6/2. 6/2 plus 1/2 make a total of 7/2. And 4 plus 1 make y to the 5th. Now when we have fractions, it's pretty much the same thing, but you might have to look at the denominator a little more carefully. So when we're doing fractions, in the top I have x to the 8th, y to the 8th, no big deal. In the bottom though, you see that we have a rational exponent, 1/2. If you don't remember what that means, 1/2 is the square root. So if it helps you to rewrite this as the square root of 64x squared, like, oh, that's a perfect square. The square root of 64 is 8, and the square root of x squared is x, so it's just 8x. And now we can simplify a little bit. Because you have 8 x's in the top and 1 in the bottom, you're going to cancel one of them out, and now you just have 8 in the bottom. So that cancels out, and now it becomes 7. Same kind of problem here. 1/2 squared, you multiply 1/2 times 2, you get 1 whole, y to the 4th, over. Now this is the cube root of 27x to the 5th. So you can break this down. 27 is 3 times 3 times 3. That means a 3 is going to come out. And if you're looking for groups of 3, there will be one group of 3x's, but we still have 2 of them trapped underneath. So you could write it like that. Or if you want to do it with the actual exponents, it might make more sense if we were to just say, okay, we know the cube root of 27 is 3, but then I'll do this as x to the 5/3. The reason I kind of like this better is because now I can deal with those, and I can say, I can subtract. So if you have 5/3 in the bottom and this is 3/3 in the top, you would subtract, because 3/3 is 1 whole. 5/3 minus 3/3 is x to the 2/3, and then we still have y to the 4th in the top. So y to the 4th over 3x to the 2/3. Remember, 1/3 is a cube root. So that's if you're dealing with them as rational exponents. Now let's do some radicals. So first one's pretty straightforward. I'm going to just remind you that when I do these, I'm going to factor. So 2 times 64, which is 2 times 32, which is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. 2, 4, 8, 16, 32, 64, 128. X, Y, Y, Y. So this is all underneath the radical. And since it's a square root, I'm looking for groups of 2 of the types of numbers. So 2 of them, 2 of them, 2 of them. Now for every 2 underneath, one of them comes out because the square root of 4 is 2, so 2 comes out. Another 2, that makes 4. Another 2, that makes 8 on the outside, and then you have a y. Radical, what's left on the inside? 2xy. 2xy. Same thing here, but with a cube root. So 5 times the cube root of 250 is 2 times 125. 125 is 5 cubed. And then I have x to the 7th y. I'm not going to list all those out. Looking for sets of 3, since it's a cube root. So a 5 comes out. Now we have, with another 5, 25 on the outside. How many groups of 3 will there be if you have 7 x's? There will be 2 groups of 3. One's going to be stuck on the inside. So that's all that can make it out. Now I have the third root of, I have a 2, I have 1 more x, and I have 1 more y stuck in there. 2xy again is the radicand. Couple more like that. Let's go ahead and factor 40. So 4 times 40 is 8 times 5. So 2, 4, 8 times 5, and then x to the 4th y squared. So again, cube root, we can bring out a 2. There's already a 4 out there, so now it's 8. I can bring out 1x, but I still have a 5 on the inside and x on the inside, and those y squares just don't have enough. So that's it. 8x radical cube root 5xy squared. 64, let's see. 64 is a bunch of 2's. 2, 4, 8, 16, 32, 64, x cubed y to the 8th. So we're looking for sets of 4 now. 1, 2, 3, 4. 2 makes it out. There will be 2 sets of 4 if you have 8 y's, so 2 of them will make it out. So 2y squared on the outside, then the cube root of, I got a 2, and an x cubed, so 4x cubed on the inside. There's your exponents and radicals. Let's do a little factoring on the back. So factor completely. These first two, I think, are both sum and difference of cubes. This is a difference of cubes. If you don't remember the rule, it's a, b, a squared, ab, b squared. But when you factor everything, you're going to start with GCF. So bring out an 8. Now you have 8x cubed minus 1. So if you look at these are both perfect cubes. 8 and 1 are both perfect cubes. So if it helps you to write them out, a would be 2x and b would be 1. It doesn't matter that it's negative. Sometimes that bothers people. Just leave the negative alone. It's 1 cubed is 1. Now I'm going to use the rule. A and b are 2x and 1. So 2x, 1. A squared, 2x times 2x is 4x squared. Remember, it's a quantity squared. 2x times 1 is 2x, and b squared is 1. And then for the signs, you're going to do SOAP. So if this is a minus sign, we're going to make that the same. Opposite. If that's a minus, this is plus, and this is always positive. Don't forget your 8, your GCF. Now you are completely factored. So that's your answer. This looks factorable, but it's not going to be. Sometimes it's tempting. Same thing here. The cube root of 27, x cubed is 3x. The cube root of 1 is 1. So it's going to look very similar. We're going to have 3x and 1. 3x times 3x is 9x squared. 3x times 1 is 3x, and 1 squared is 1. Same, opposite, always positive. Same as what you start with, opposite of what you start with, always positive. So there's second sum of cubes. Sometimes you'll be asked to factor out some quantities. So when you factor a problem like this, what you want to first do is look at the 6 and the 9. Do they have anything in common? They do, a 3. Then we'll look at the x plus 1s. This guy's only got 1 that he can factor out, so I can factor out 1x plus 1. And then we'll look at the x minus 4s. They both have 2x minus 4s, so x minus 4 squared. That's my big GCF. On the inside, I got to think, what do I multiply by? 3 times 2 is 6. This has 1x plus 1, but I need another x plus 1. And x minus 4 is taken care of, minus. 3 times, what gives you 9? 3. X plus 1 is good, x minus 4 is good. So that's it for the inside. We just got to simplify it. So distribute 2x plus 2 minus 3. Combine like terms. 2x, 2 minus 3 is negative 1. So that's one of my factors. And then don't forget, that's your other factor. So I'll write that out front. If you want to leave it in brackets, you can. Parentheses are fine though too. Couple more. Let's see, just kind of a free-for-all for factoring. Okay, what if I give you 4 terms? If I give you 4 terms, that's factoring by grouping. You still start off with GCF, even. Oh, even, they're all even. Bring out a 2. 2, 9x cubed minus 27x squared minus x plus 3. Now, since it's 4 terms, we're going to factor by grouping. So you find the GCF of the first 2 terms and the GCF of the last 2 terms. GCF of the first 2 would be 9x squared, and you'd be left with x minus 3. If that's a minus sign, bring down the minus sign. And then these two don't have anything in common, so I'm just going to bring out a negative 1, which makes this x minus 3. Because if you distribute, you get negative x. Negative times a negative is positive 3. That gives us 9x squared minus 1 and x minus 3. I still have a 2 on the outside. Don't forget about that 2. We're almost finished, but when you have nonlinear terms, you better make sure, like 9x squared, that's a perfect square. 1, that's a perfect square. This is dots. So you can actually keep going in this one. This would be 3x plus 1, 3x minus 1. I still have x minus 3, and then I put that 2 out front. So now I'm completely factored. Make sure you look for dots or sum of difference of cubes. Do another one. There's no big GCF, so I'll find the GCF of each half. The GCF of those two would be 8x cubed, and I'd be left with 2x plus 1. Bring down the minus sign. Again, these two don't have anything in common, so we're factoring out a negative 1. Be careful with that sign. So now my terms are 8x cubed minus 1 and 2x plus 1. That I can't do anything else with, but those are both perfect cubes. So I'm going to do my sum and difference of cubes formula, which would be 2x and 1. 2x times 2x is 4x squared. What are my signs? Same, opposite, always positive. Okay? So again, this looks like it might be factorable, but when you use your sum and difference of cubes formula, you don't need to worry about it. It's not going to be factorable. Last couple problems, we'll factor out some negative exponents. So the trick to these is you want to factor out the negative exponent every time. 10, 25, and 60 are all multiples of 5, but then I'm going to bring out that x to the negative 1/2, x to the negative 1/2, and now we'll see what we need to do to distribute back in. 5 times 2 gives you 10, and this is where it's tricky. X to the 3/2 divided by, because that's really what we're doing when we're factoring, is the same as adding. Subtracting a negative 1/2 is the same as adding. So 3/2 plus 1/2 is 4/2. 4/2 is 2 whole. Plus 5 times 5 is 25. And again, 1/2 minus negative 1/2 is the same as adding. 1/2 plus 1/2 is 1 whole. Minus 5 times 12 gives you 60. The x minus x and negative 1/2 comes along for the ride. So it's kind of weird. But now that we've got the negative factored out, we're just going to look at what's left, and that might be factorable. What multiplies to, if I split the middle, 2 times negative 24, what multiplies to negative 24 and adds to 5? Let's see, 2x squared to be positive 8 and negative 3 when you split the middle. So then I'm grouping 2x, x plus 4 minus 3, x plus 4. So my factors are 5x to the negative 1/2, then I have x plus 4, and then I have 2x minus 3, and now I am completely factored. Just make sure you keep going, because if you have a quadratic, it might still be factorable. One more, factor out, let's see, 4 and 12 are both multiples of 4, so 4 coming out, and then I'm going to factor out the negative exponent, so x plus 2 to the negative 1/2. Now, when you factor out the whole thing, you need that placeholder there. For that whole quantity times 1 will give you that whole quantity, plus that whole quantity times 3 will give you 12. But then again, you have 1/2 minus negative 1/2 is the same as adding. So this will be x plus 2 to the first power, which you don't really need to write the 1, but you can. And now we got to distribute and simplify the red. So 1 plus 3x plus 6 will give you 3x plus 7. And then don't forget you had a 4, you had an x plus 2 to the negative 1/2. And now we are completely factored. If you can do the study guide, you can do the quiz. So good luck.